All right, ladies and gentlemen, welcome to a lesson about combining the exponent laws. So we have learned all our individual exponent laws, the multiplication, the division, the power to a power, what to do with negatives, what to do with zero, okay? Now what we're going to do is we're going to kind of combine them all together. What happens when I see a problem that has more than one law at a time going on? There's going to be a set order I'm going to have you guys follow through to look at these. That way you kind of always kind of have a set pattern to look for, and then always make sure that you get the correct answer at the end. The first thing I'm going to have you do is to look for a zero exponent, okay? If you see one of those zero exponents, so anything raised to the zero power, you do not have to follow any other steps. It's kind of like the secret shortcut. You see a zero exponent, you should be jumping for joy, because what that means is that you can then go ahead and to the problem, because once you see that zero exponent, you know that the answer is going to equal 1. So zero exponent means your answer equals 1. Jump for joy, you kind of get to skip what you're doing there, okay? After you look for the zero exponent, the next thing you're going to do is you're going to do the power to a power rule. Okay, you're going to look for those power to a power laws, all right? So if you see an exponent to an exponent, that kind of thing, you're going to go ahead and multiply those exponents together and do your power to a power rule. After you do your power to a power rule, you're then going to look for a multiplication rule. Okay, when you do the multiplication rule, what you're looking for is kind of in the numerator denominator if there's a fraction in there, but any sort of on the numerator denominator, any of the same bases that you can add the exponents together. Okay, after you do the multiplication rule, then you're going to go ahead and do the division rule. Okay, the next thing you'll do is the division rule. Okay, so after you do that multiplication rule, you'll then go ahead, do your division rule, divide everything, do whatever. I will tell you that in 3 and 4, you're going to go ahead and just ignore negative exponents for right now. Just add them together, whether negative. When you do division, subtract them like they're negative, whatever. We're going to deal with negative exponents at the very end. The 5th step is going to be to move any negative exponents. And again, like we talked about with negative exponents before, you flip them to the opposite side. If they start in the numerator, you're going to move them to the denominator. If they start in the denominator, you'll go ahead and move them to the numerator. But the last thing you'll do is go ahead and move negative exponents around. Now that we kind of see all these steps that we're going to follow, starting with looking for a zero exponent and then moving all the way through down to moving negative exponents, let's look at what that looks like in practice with a couple problems. First off, example A here, I have x to the 4th, y to the 8th, z, x to the 4th, y to the 2nd, to the 5th. According to this, the first thing I'll do is look for a zero exponent. Well, I don't see one here, so I don't have to worry about that. The next thing I'm going to do is do the power to a power rule. Well, I see I have a power on the outside. You see everything in parentheses to a power. I'll go ahead and do that. Let's see, x to the 4th, that's going to become x to the 20th. And then the y is going to become y to the 40th. The z I know has a secret 1 hiding here, so it's going to become z to the 5th. The x is going to become x to the 20th. And this y is going to become y to the 10th. After I do my power to a power rule, the next one I'm going to look for is the multiplication rule. And I can see here that I have things like bases being multiplied. I can go ahead and add those exponents together. So 20 and 20 is going to give me x to the 40th. The 40 and the 10 is going to give me y to the 50th. And the last one, the z to the 5th, is going to just stay by itself. It has nothing to add to. Then I'll look for division rule. I don't see any division going on. Move negative exponents. I don't see any negative exponents. This is going to be my final answer right here. There's my fully simplified expression. Let's go ahead, let's look at another one over here. I'm going to start again by looking for a zero exponent. I don't see one, so I'm not going to worry about it. Next thing is power to a power rule. Oh yeah, I see I have power to a power, so let's go ahead and multiply each one. Now, like I said, when we talked about the power to a power rule, we are going to do kind of like just the numerator and the denominator. So here I have x to the 3rd, so this is going to become x to the 9th. The y to the 8th times 3 is going to become y to the 24th. In the denominator, now there's a secret 1 hiding with this x. So x to the 1st times 3 is going to become x to the 3rd. And then the y becomes y to the 12th. Next thing I'll go ahead and do is look for the multiplication rule. I don't have anything being multiplied that has a like base, so I cannot add their exponents together. The next thing I'll look for is division rule. I do have division rule, which means I subtract the exponents. 9 minus 3 is going to give me x to the 6. And 24 minus 12 is going to give me y to the 12th. Then I'll look for negative exponents. Don't have any of those there. This will be my final answer. Last but not least, we have this one over here. We're going to go ahead and follow our steps again. Again, I do not see a 0 exponent, so I don't have to worry about that. I do, however, see power to a power rule again. You'll notice in these problems, power to a power rule comes up a lot. We'll go ahead and we'll do that. I know that these numbers secretly have exponents of 1. So if I do that, I'm going to get 5 to the 2nd. A to the 5th times 2 is become A to the 10th. B to the 3rd times 2 is going to become B to the 6th. 10 to the 1 times 2 is going to become 10 to the 2nd. A, I know has a secret 1 hiding there. It's going to become A to the 2nd. And then 9 times 2 is going to give me B to the 18th. Before I move on, I need to fully finish this power to a power rule, which means I need to evaluate these coefficients out front. So I know that 5 to the 2nd is actually 25, so I'll go ahead and write that as 25. I also know that 10 to the 2nd is actually 100, so I will go ahead and rewrite it as 100. I'll then go ahead and go to the next thing, look for multiplication rule. I do not see any multiplication rule here, so I do not have to add any exponents together. The next thing I'll go ahead and look for is division rule. I do see division rule, so I'll go ahead and do that. 25 over 100, if I use my ABC trick, I'm going to get that that is 1/4. 10 and 2 is going to become A to the 8th. And then 6 and 18 is going to become B to the negative 12th. Last thing we're going to look for is negative exponents. I have a negative exponent here. We need to move that to the denominator. So let's go ahead and move it to the denominator. This is going to become A 1 times A to the 8th over 4B to the 12th. I moved it down into the denominator. You do not have to write this 1 here. You can just write it as A to the 8th over 4B to the 12th. If it makes you feel better to write it, though, you are not incorrect. I do not care how you write that. All right, I want you guys to go ahead and try these ones right here. You have a D, E, and an F here. Go ahead and try each one of these. And pause the video, give them a try, then come back and check and see how I did. All right, hopefully you went ahead and gave each of these a try and back with me. D was one of those ones where you're jumping for joy. That's one of those ones where in the first step you see a 0 exponent. Yay, 0 exponent. 0 exponent is cause for celebration and party because it means you can kind of skip the problem. That's a really scary smiley face, it is true. But you can kind of skip the problem. Oh yeah, it's going to equal 1. Okay, so you see all these letters, all this craziness. It just equals 1. It's to the 0 power. With E, you had to go ahead and do your power to a power rule first. You get x to the 15th, y to the 5th, c to the 45th, x to the 5th, y to the 40th, and then you can use your multiplication rule to combine some of these like bases together. X to the 20th, y to the 45th, c to the 45th. Last but not least, you have this one over here, F. You have to go ahead first and do your power rule, a to the 12th, b to the 9th, over a to the 3rd, b to the 21st. I don't see any multiplication rules, so then I'll go ahead and do the division rule. I end up with a to the 9th and b to the negative 12th. Let me circle these. You know this is the answer. Okay, and then after I go ahead and I do that, I look and say, oh, I have a negative exponent. It means to move to the denominator, and this is what your final answer will be. Okay, so this is how you combine the exponent laws together. Kind of a quick little note sheet here for today, but I really hope you guys got a lot out of this. This is what we're going to be spending the next couple days on, is really just putting these laws together and seeing how they work with each other. Once again, I hope you guys have a great night. Thank you for watching.